Hello everyone, hope you all are doing well. You are welcome to the second part of our data processing fundamentals with live Python code series. In this video, we are going to continue where we left off at the very first video. So we are going to start at the same place, same ID, same code, and the same flow with the content as follows. We will carry on our work where we stopped in the previous video, and we are going to add the more filtering by using the various kinds of column types, including the categorical. Next, we will make sure that the code which we have written, it works with multiple data sets which are available in the Python Seaborn library. I'm showing the two different data sets, but you are welcome to even add more data sets and make sure that your code does work. Next, we will learn how to write the inline coding where we could reduce the multiple lines of code within a single line of Python code. Next, we will learn how we could write a better code by adding more function to our Python application where the code is being duplicated in multiple functions. That way we can write the better code, cleaner code, and much more functional code, along with writing the commands for every function, which is going to help others to read the functionality behind the given function. And that's where we are going to stop this second part of our video. At this point, your application will be complete to run, load with multiple data sets available in the Seaborn library, which will be ready for you to try. That's all for now. So let's get ourselves coding. Now we need to write another method where we could actually filter the values from the categorical fields. So if you see here, the categorical fields are cut, clarity, and color. So these are the categorical value. Rest of these values are the numeric value. One more way you could get the idea of numeric value is that what you do, you use the data frame and you run the describe here. When you are going to look into the describe, you are going to get the values related with your numeric field. So these are all the numeric fields which is part of describe result. So let's write the second method, and we are going to call that method is the get records by category. So I will be copying the same method and I will just make few changes to it. So we will call it get dataset by category. So we need to validate that field correct. So this method we really need it. Now let's take a look into the field type. So we are going to select here the field name, df, top, just one record, and the categorical fields are cut, color, and clarity. So you have df cut dot d types. You will see the value is, let me use the d type, and the value is categorical. So for the category, we need to actually use any of these value as a category. So how you can validate it? You can actually take the d type and you can validate if this value in category and result is true. It means this d type is validated if it is category. So we are going to use this same category as I used here. So the field type validation is categorical. So this will be used here, field type. Now the field value in all scenario, the field value must be a string. So now we need to make sure the field value is a string, because whether you will use any of these string characters. So if you have this dot type, this is a string, dot name, it's going to be str. So the field value in this scenario, when we are talking about category, it has to be equals to str, or if you want to use in, then you can convert this to a list. So now field value validation, field data type validation is a category, and now we need to look into the comparison. So we do not need a comparison because I'm coming into there. So we want to get all the records which are based on all the ideal. So let's look into the df1k. These cut values are all kinds. Let's try to select only ideal. So what you could say, you can say give me the df1k, and you select df1k, the value you want, cut, and you say is in. You see that there are 333 records out of 1000 which have ideal cut. If you are looking into the values which are ideal and good, you can actually add both of them. Now the ideal and good is listed here. If you will add X here, you will say that X does not matter here because is in. So it checks and it makes sure that whatever you are listing, those union is available. It means even if none of the X are available, still that does not matter because X does not exist here. So for that reason, because this is our method which is going to be used here, so we do not need the condition. So condition is not needed. It's just a very simple. So df of df field name in, we need to look into field values. So we can store this value as a df. There is a one more change we need to make because field values, it must be field values. So here is the field values, and we also need to make sure that the field values are available in the list. So it must be a list. Whether you are selecting one or many, still it has to be in a list. So first we need to make sure that if length of field values is greater than 0, and not only that, we need to make sure for each field in field value, and here we can, for each value we can just set up a counter. Correct count is equal to 0, and for every correct value we are going to say is +1. And finally we can come here, if correct count is equal to the length of field values, if this is okay, our comparison is true. This whole code can be changed into a one line of inline method as well. So I would say that when we try to enhance this method, I will write here, I will say to do, but right now we are going to use it as it is. So we have get dataset by category, df, field name, field values, and this is the method we are going to use. So this is the method which has to be imported here to be used. Let's use df equals, pass the df, and we are going to use the field called cut, and values we are going to use the, let's do not use this method, so we will know if there is any issue with this. Okay, and let's come back here, debug. Okay, let's run one time. Okay, the df right now has 422. It means records out of 1000 there are 422 results. Let's come back to output. Here you could see that cut has ideal and good only. If we take this and use the clarity and use only si2, so we are going to select the and si2. Let's run it. All values are si2. If you use color and use color as e, all the e color, it means that you have ability to get the data set either by value or the category. Let's use this first, and we want all the diamonds which are carat 1 or above. Let's run it. Now we say that within this category we want all the diamonds which are in premium type. So we will use the cut as a premium, and the combination of these two will be all the records with carat above and the premium cut. As you could see here, 1 and premium cut. If you would want the clarity as the A, B and C, so you can also use cut. You can say color A, B, C. There is no A, B, C, D. Only one above 1 carat. There is only one diamond which has D, E. Now you are getting D and E. It means this code, the way we have written, it's going to work and going to get us the results depending on how we would want to filter our data set by values or by categories. Now we need to check the code which we have written. Does it work with other data sets as well? And as we know that the SNS get data set names already has various other data sets. So we wrote code by using the diamonds data set as our main data set. However, let's try to apply this same code for the planets and see if our code works without any major change. Let's come back to main here, and here we can write a function called define process selected dataset, and based on the selected dataset method we will check which dataset we would want to work right now. So we will use get dataset here, and here will be dataset name, and this method is actually going to call the selected dataset. So right now it's a dataset diamond and the dataset. So this code is just same. We have just added one more method here to make sure that it does work for us. Now in this dataset, we need to make sure that the person or the request to a certain dataset is valid or not. All SNS datasets equals to, we can import here Seaborn as SNS, and we can say SNS dot get dataset names. That's what we are going to have the list, and we can say if the selected dataset name in this list only when you make a call. Otherwise, we should not make a call because the dataset will not exist here. Here, remember that depending on which dataset you are going to choose, we need to make sure that the value related with filters are correct according to fields. It means we can actually make change here and say if dataset name is equal to diamonds, only then this code is going to work. Otherwise it will not work. Rest of the code is designed in a way that it should work as it is. So let's put 100 records sample and run this code. Okay, so this is our code with the diamonds. Now let's use planets. The code does work. 100 records are printed and there is no filtering done because it's not related with filters. So we could say else if planets, we could perform another set of validations. So here you could say we want all the planet, the number, because we need to know which columns have the values and which column are the categoricals. So we can say the mass is really look like good. So mass greater than equal to, so here is the mass, let's use 1.0. Run this code now. 28 records. So that code did work. We have also seen the values here are the radial velocity. We do not know what other options are, so we can actually get that value from here. SNS.load dataset planets. So that's planet dataset. Here you could actually either store in data frame or you can get the value like method. You can say radial velocity transit. If you want all the unique value, you can say unique, and it gives you all the unique values which are available in this field. Now you can build your categorical filter. So let's, here field name is method and field values are, let's use these values. Let's run the code now. Let's take a quick check here because the filter did not work. Let's put a breakpoint here, run the code, field values, okay, and categories. So let's see here, okay. So field value is true, field name is true, okay. Now here we are looking into field type is object here. So the problem what we are seeing here is if we look into, this is actually the object type. This is not the category right now. So the way this column is created is that this column is just a string values are there. That's why it's showing the object. So if it shows the object, basically these all values are string. And because our filter method has to follow the category. That we can actually add one more field called object here, and it means this code should work. So if we have added object here, we can go ahead and we can give a quick try. And based on our filter value here, amazing everything, the result shows that there are 0 records here. If we do not use this, let's use the radial velocity. It means this working for 27 record with radial velocity. If we do not use this and run, we will see 27 record. It means all the records are the radial velocity. We can change this to 1000. Let's run 273. Now let's enable this 266. It means there are some other records which are not the radial velocity. Now we can enable this code back and let's see if there are any other records which are part of this group. There are 3 records: transit and eclipse timing variation. So at least you can get an idea that the code which we have just updated, it does work. And now we can go back and look into the diamonds and see that everything is working as it is for the diamonds or not. So we have 1000 record, 29 are above. If we change this to 0.2 and above, there should be at least 1 record. 2 records are there. There you go. It means our code does work from both of these conditions. Now, if you try to add even other data sets which are available in the SNS, they are all going to potentially work. That's our expectations are. Another aspect of writing better programming is to add the comment in your methods, and you can do that by using the double quotes. So 3 double quotes is going to give you details about the comments which you could add in every function. Here you could say the definition will be getting the list of data frame. So param df, the input data frame, and return will be. So this is how you can make sure that your method is documented correctly. Similar to that, you could also do it here. So this is just a sample for you to add the comment in your function. Here, as you could see, that we are validating the field, because remember in our code we have validated the field name. So if you would want to validate the field name, we are validating 2 places. We could convert that to as a new method called define validate field name, and we can pass the data frame and the field name, and it will return this value here. Let's use this method. So here we are getting all the columns. This is the false, and it's going to return field name validation, and field name validations equals to this method with df and the field name. So similar to this validate field name, we can also use here. So our code is even more cleaner. After that, we can just run this code to make sure that our code is working. Okay, that no problem with that change. Validate field. Now we can actually say field type and value. So you can also say define field type and value. So you can say validate field type and value, and here so these are the numeric field data type. Okay, so we just call them numeric field data types, and here you are going to pass field value validation. Let's take this code, and you need the field value type. So you are going to pass this. So you are going to take this method, you are going to pass this value, and this value is going to give you the validation, and return here is field value type is the numeric field data types. So this method, we have just, if the given field value is a numeric data type, true, otherwise false. And that is what we have just passed here. Similar to this, if you would want to convert this as well, you could actually say, and here field type is this definition is not really needed. So now this code is became even more cleaner, and then validation is much more cleaner now. This can also be converted into correct conditions or operators. So this is the operator conditions. And next, define conditions. If we run our code, the validation shows that it should work. Perfect. We can also make sure that if we change to planets, yes. In our next step, let's fix this code, which looks really dirty, and convert it to one single inline code. So I will go ahead and set up a breakpoint here. Let's debug it. So the field values are, these are the field values, and what our code does is that it just look into each field value and make sure that they all are a string. It means that if there are 4 values, there should be total 4 string comparison. As long as there are 4, condition will be correct. So I will open the debugger, and here we can look into the field values. So here are our field values. So you can write an inline method. So you can say item for item in field values. If you run, it actually return each item. So for item in field values, result is the item. So all values are there. Now we can add a condition here. We can say if the type of item dot name in str. So that's our condition. If the type this in str, that's our condition. If this condition is good, so if type name condition, let's run, and you see here that it returns all 4 values as it is. By any reason, if these 4 values, one of them are numeric, the result will be 3, and we will just validate it. So that's our result. Now what happened is that we need to get a length of this. Here is the length of it, and the length is 4. It means this will be our code. So now we can close it, run it as it is. Here we can take this whole code, comment it, and our condition will be if length of this is equal to the length of field values. This condition is true. And let's run it. Right now there are 3 records. Run it. Still there are 3 records, and we can validate this. At this point, the data frame, yes, condition is true. Let's come back here and change the condition. We are using planets. These 4 methods are there. Let's add one condition, 20. So 1 is numeric value here. Take this, run it 4. So the length of field values is actually 5, but result is 4. This condition will not be true out, and that code will not run. So this comprehension of the code compressed into a one single line is just much more cleaner code. Sometimes if you don't understand, it's become a little hard to understand, but once you decipher each piece of the code, this code has 3 pieces. One, it returns this. For each of this value is validated. If this value is validated, it is stored back to in this system, and finally we generate the length. So I will just leave this code so if somebody cannot understand, they can have better understanding of this code. So let's take a quick review of this code before we complete this session. So we started our code by writing the main method, and slowly we first created this dataset.py and we implemented various methods so that we could process our dataset request based on get dataset method. We have ability to process our data frame depending on various features. We can filter total number of rows, and then we can also filter various columns. And if you are using this code, I will request you to please apply the same code for various other data sets which are available in the Seaborn Python library. And if you find any issue, please do let me know. So that's where we complete our second part of Python based data processing fundamentals series. This code is ready for you to try and apply to various data sets as applicable. I do appreciate your time, and I'm going to look forward to seeing you in my next video related to with the same data processing fundamental series. Until then, thank you so much.